Good day, Calc students. Today we're going to talk about the last concept in the calculus course. It's called slope fields. And at first glance, you'll look at a slope field and go, I have no idea what I'm looking at. But I think you'll find with this example and two others beyond this film, slope fields aren't too terribly difficult and very useful, especially when you have a differential equation that cannot be separated. Let's look at this right away. With problem number 1, it says create a slope field on the provided grid. We're going to have differential equation dy dx equals negative x plus 1, and there's the provided grid. So to do a slope field, what you need to do is to create a table. You need to decide upon which table format you need to use. It's either a table that has column 1 x, column 2 dy dx, or column 1 is y, column 2 is dy dx, or column 1 is x comma y, then dy dx. Well, because this differential equation is written in terms of x only, my table needs to be written in terms of x only. And of course, the second column with all such tables is labeled dy dx. So I'm taking a look at the x-axis on the provided grid, and I see I'm provided x values between negative 3 and 3. So on my table, I list the x values between negative 3 and 3. Now what I do with each one of those is I put them into my differential equation. So I put a negative 3 in for x first of all, and I got 4. Let's see how. So if you look at your differential equation, you have to take the opposite of x. So I'm taking the opposite of 3, which is 3, and adding 1 and getting 4. So when x is negative 3, dy dx is equal to 4. I'm going to complete my table doing the same math for each input. Now it's time to complete the slope field. So the first thing I do is I find something easy to plot. Dy dx of 0 is just a horizontal line. A slope of 0 is a horizontal line. So what I'm going to do is go to the ordered pair 1, 0 and put a horizontal line there. In fact, you'll see this horizontal line exist for all x values that are equal to 1. If you take a look at there, the group of horizontal lines all have x value equal to 1. Now let's go to where the x value is equal to 0. This coincides with the y-axis. All along the y-axis, as low as negative 3, as high as 3, I'm going to have a slope equal to 1. That means like up 1, right 1. So it would be a perfect uphill slope. There's x input of 0. At 3 I have a slope of 1. And on down to negative 3 I have a slope of 1 everywhere there. I continue with this format. The next easiest one perhaps to plot is slope of negative 1. So now I locate the inputs of 2 on my x-axis, and at 2 I have a slope of negative 1. And all the way down the column I have a slope of negative 1. Okay, so now my slopes are going to become a little steeper. I notice at negative 1 my slope is equal to 2. So I find x value negative 1. Now you see those little dots I put on there? I'm focusing on the little square from negative 1 to 0. And I'm just going to go and use a tiny square in order to aim this slope correctly. So I know a slope of 2 is up 2 and right 1. So I go up 2 and right 1 to develop an aiming point. Right there, that circled point, if I start at x value negative 1 and aim toward that small point, that will give me a true aiming point of a slope of positive 2. It's a little trick of the trade. So there's my slope of positive 2. You can see that that slope is aiming at that aiming point. Use a tiny square to do so. So now all of my slopes at negative 1 are going to be parallel to that one. Ding! Got them. All right. I'm playing the same game in plotting slopes of negative 2. So I go to x value 3. and I've got a tiny square there, and I locate my aiming point, which is right there. That gives me a nice slope aiming point, and I aim right at that point, and that's giving me a slope of -2. Notice how that downhill slope is a bit steeper than the slope of -1. And that's got to be the case if you're to correctly sketch one of these slope fields. Now I just hit the entire column with parallel slopes. Well, I'm now going to x value of -2, and the slope is 3. You know, the only thing I'm talking to myself about here is, hey, I'm going uphill from left to right, and it's pretty darn steep. It's got to be steeper than the guy right next door. So here's what I sketch. Don't outcoach yourself. Your precision here is not necessary. It's just when I compare to the guy next door, it better be uphill, number one, and it better be steeper than the slope to the right, number 2. And then at -3, I got a slope of 4. That thing is got to be a positive slope and nearly vertical, like this. Ding! Got him. So there's my slope field. Now, if you kind of blur your eyes, you can maybe pick out a point and picture what the curve might look like through that point. Here's what I'm talking about. Just redrawing here the entire slope field along with the grid behind it. And now my challenge here is going to be see if we can utilize this slope field. I want to use the slope field and draw a solution through the order pair 1, 2. So I locate the order pair 1, 2. There it is on my slope field grid, right 1 and up 2. And now I just move to the left and follow the slopes that I'm given. I kind of try to keep my curve parallel to the slopes on the left. I do the same thing moving to the right, and I just try to keep my graph parallel to the slopes headed to the right. And so that's what you would be asked to do on like an AP exam dealing with slope fields. It would ask you then to show what a solution might look like through a specific ordered pair. Now, you guys have been down this road before, and we have successfully solved these differential equations. Let's see if we can quickly do that here so you can understand how what we just drew corresponds to the solution to the differential equation. So I've got a separable differential equation here. I'm going to get the dx on the right, and then I'm going to integrate both sides. When I integrate the left, I get y equals. When I integrate the right, I get -x squared over 2 plus x plus c. You know, you just pause this up when you need to if you got to rewind if we're moving too fast, okay? So now I've got an ordered pair to utilize. I want to solve for c. I've got the ordered pair 1, 2, where x is equal to 1 and y is equal to 2. I put those values in. The 2 is equal to y. There's equals. Instead of x, I'm putting in 1. Don't forget to square it over 2. Plus, don't forget to put in a 1, plus c. I'm now going to use my skills to solve for c. Well, -1 squared, that's not -1 quantity squared, that's just -1 squared is gives me -1/2, still on the bottom, plus 1 plus c. I get 2 equals 1/2 when I combine like terms on the right, plus c. Subtract 1/2 on both sides, I get c equals 1.5. All right, now if I put that c value back into y equals, so now I've got a great equation for y equals. I get -x squared over 2 plus x plus 1.5. If I took out my graphing calculator right now and I graphed that bad lad, you would find that it looks like this. And you can see the equation in the upper left-hand side. So are you noticing something here? That point is 1, 2. That's the same point you drew. And the slope field, the lines that you drew, ended up looking like a parabola that opened downward. Same parabola that opens downward here when you solve the differential equation. So that's what's got to hit home for you. Okay, so that's example 1 of a slope field. Again, example 1, simple. Example 2, up and coming, is going to be intermediate, followed by example 3 that's tough. Slope field in a nutshell, see if you can work a problem like that. Example 2, come on up. Over and out.